Hello again. So now we'll talk about the virtual design tool. So the virtual design tool is developed on the basis of the program VREP, which is a robot simulation tool. So here you see some examples from the three use cases. On the top right, we have the IMA use case. On the bottom right, the Whirlpool, and on the bottom left, the Schindler use case. So what you see here is basically the normal VREP functionality. You can create virtual scenes with the machines, robots, walls, cameras, and workers. Additionally, you can visualize, for example, on the bottom left, you can visualize the actual field of view of the cameras, or you can mark certain areas as collaborative areas, which we have done here in orange and lila. Now we added the Rossini specific functionality to this VREP tool. There are basically ways that you can extend the functionality. You can use the internal VREP scripting language Lua, or you can also write C++ plugins that can interact with the workspace in this virtual scene. So here you see, as an example, the Rossini custom GUI. With the first functionality tab, which is the camera functionality. So you can switch on and off the cameras. So what I have to say is all these virtual scenes you can actually simulate by starting the simulation. Then everything starts moving. The robot starts moving, the human starts moving, like in a real scenario. And this moving scene can be filmed by a virtual camera. And this you see here on the right, it's a camera image in grayscale produced by a VREP camera. This is also an example of how you can interact with software outside VREP. It allows you to publish these camera images via ROS, and then you can apply what I said earlier in the other presentation about the semantic scene map. You can actually test the semantic scene map software on these simulated images. And here we see an example of the object detection algorithm applied to the simulated images. Here we see more examples of the functionality that can be controlled by the Rossini custom user interface. First, we have the robot movement panel. You can either start moving this robot by using the Lua internal scripting languages of VREP. So if you hit start, it will move according to a trajectory which you define inside that Lua scripting language. Alternatively, we have written a C++ plugin which uses ROS to create a robot trajectory and then interacts with the VREP scene to move the robot according to that trajectory. So you have various options here with different buttons. The next one is safety measures. Once the scene moves, you can tell VREP to measure the closest distance between the robot and the worker, and you can program it to display it in red or orange according to a distance, which is if the robot and the human become closer than a certain distance you define. This is seen here on the right where the worker has an orange hand. This is another example of interacting between VREP and the semantic scene map software. So in this case, we again use a simulated VREP image and apply the semantic scene map skeletonization algorithm to that image. And in this case, the skeleton is overlaid on the image, and this is visualized outside VREP, just using the normal AVIS tool of ROS. But we went also another step further. In this case, we actually use a normal image from outside VREP with a normal camera, apply the skeletonization algorithm of the semantic scene map as seen on the left, and then using the plugin, another C++ plugin, use the coordinates of that skeleton and draw it inside the scene, inside this VREP scene. So this way you could simulate or set up some test outside VREP in the real world with a table and some working area, and then combine it with a robot inside VREP. So here on the right, you see the human skeleton created from outside VREP in the background, and the actual VREP human is in the foreground. And you could move the background human closer to the robot. This is all configurable, and you can then simulate like a combination of a virtual scene and a real scene. Okay, this is it for the virtual design tool. Thank you very much.